All right, today we are digging into a rule that, let's be honest, completely took over our lives for a while. Social distancing. We all did it, but where did the science behind it actually come from?
You know the one. 6 feet apart, 2 meters. It was everywhere, right? Taped on the floors of grocery stores, repeated endlessly in public announcements. It became this global mantra. But have you ever really stopped and wondered, where did that specific number, 6 feet, even come from? Well, the answer is a whole lot messier than you might think.
Okay, so first up, a quick bit of housekeeping on the terminology. We all got used to saying social distancing, but really, the more precise term scientists use is physical distancing. The point was never to cut ourselves off socially, right? It was just about creating that physical space to stop a virus in its tracks.
So, let's talk about that spacing. Why does it even matter? The goal, at its core, is incredibly simple. And to really get it, we need to talk about one of the most important numbers in all of epidemiology.
And that number is called R0, or R0. Now, this isn't some fixed magical property of a virus. Think of it more as a performance review. It tells you, on average, how many other people one sick person is going to infect in a population where nobody has immunity yet.
And here's the bottom line. If that R number is above 1, an outbreak is gonna grow, and probably grow exponentially. But if you can just push it below 1, the outbreak starts to shrink, and eventually it just fizzles out. So the entire goal of physical distancing was to be a giant brake pedal on that R number.
And we have pretty good evidence that it worked. I mean, look at this. A gigantic study that looked at 149 countries found that just implementing some kind of physical distancing was linked to a 13% drop in the incidence of COVID-19. That's a huge deal. That's bending the curve.
So the big question then became, how far is far enough? Well, a huge systematic review in The Lancet, one of the world's top medical journals, gave us the answer. That pretty much became the scientific foundation for policies everywhere. They said, look, keeping at least 1 meter apart is tied to a massive drop in infection risk, and pushing it to 2 meters, probably even better.
But, this is science we're talking about. The story is never that simple. A nice, clean rule almost never captures the messy, complicated reality. So was that 6-foot bubble some kind of magical, impenetrable force field? Well, the science says, not exactly. And the reason why gets right down to the nitty-gritty of how a virus actually moves through the air.
See, the whole debate really boils down to this: droplets versus aerosols. The 1 to 2 meter rule is mostly built on the idea of large droplets. You can think of these like tiny, microscopic cannonballs. When someone coughs or sneezes, they get launched, but gravity takes over pretty quickly and they fall to the ground. But viruses also travel in aerosols. These are way smaller, more like a fine mist, and they can just hang out in the air for a long, long time, getting swirled around by air currents, especially indoors.
Now, to be fair, this doesn't mean the droplet idea is wrong. Not at all. That same Lancet study showed just how much distance matters. The risk of getting infected plummeted from almost 13% when you were within a meter of someone, all the way down to just 2.6% when you are more than a meter away. So yeah, space is absolutely a good thing.
But here's the catch. That risk isn't just about distance. It's about the whole context. I mean, think about it. Are you in a stuffy, unventilated room or a breezy park? How long are you there for? Is someone just talking quietly, or are they coughing their lungs out? All of these things, airflow, exposure time, they can totally change the game.
And here's where it gets really wild. Some research in fluid dynamics found something kind of mind-bending. In certain rooms, you can get a phenomenon called thermal stratification. Basically, warmer air from people's bodies rises and creates a layer up high, separate from the cooler air below. And in those situations, the risk doesn't just fade away with distance. No way. The virus-filled aerosols can get trapped in that upper layer and actually cause the infection risk to peak again, way past that 2-meter mark.
So, okay, the physics is a lot. It's complicated. But then you have to add in the single most unpredictable, chaotic variable of them all. Us, human beings.
So why did some of us follow the rules so diligently while others didn't? Well, behavioral economics actually give us some really powerful clues. It turns out our brains are hardwired with all these little biases. We've got present bias, where we value the immediate fun of hanging out with friends way more than the future benefit of not getting sick. We've got loss aversion, which makes us really hate it when rules are framed as a loss of our freedom. But we're also influenced by salience, those bright, unmissable stickers on the floor, and by appeals to our altruism.
And once you understand these biases, you can actually design policies to nudge people in the right direction. It's fascinating. Those floor markings,
They work because they make the right decision the easy, automatic one. Framing the message around protecting grandma is way more effective because it taps into that altruistic side. And hey, just telling people that most of their neighbors are following the rules, that works too, because nobody wants to be the odd one out.
But maybe the biggest psychological lever of all? Trust. It's huge. One study found that people who actually had confidence in their government were a full 14 percentage points more likely to self-isolate when they were told to. That's not just a feeling, trust literally becomes a public health tool.
So with all this complexity, the physics, the psychology, let's zoom out. How on earth did all these different countries with all their different situations land on their own specific rules?
Well, here's the thing. They didn't all land on the same rule. Not even close. There was no single global standard. You had about half the world going with 1 meter, another third or so picking 2 meters, and then a bunch of others landing somewhere in the middle. It was all over the map.
So what gives? What explains the difference? Well, researchers found something truly incredible. The specific distance a country picked, it didn't really have much to do with how bad its outbreak was. Instead, it correlated with culture. Things like how much personal space people normally keep, or whether they shared the same legal system or even the same currency as their neighbors.
To put it another way, it looks like countries were influenced just as much by what their neighbors and cultural allies were doing as they were by any specific piece of science. It seems like a lot of them just looked around, saw what their friends were doing, and said, yeah, okay, let's do that too.
So, where does that leave us after peeling back all these different complicated layers? What's the big takeaway here?
I think it's this. The science of social distancing was never just one science. It couldn't be. It's this incredible, messy, dynamic mashup of epidemiology, fluid dynamics, behavioral psychology, and even cultural anthropology. Public health isn't a simple equation. It's a negotiation between all these different fields.
In the end, that 6-foot rule was a simple, easy-to-understand answer to a profoundly complex problem. And it was a useful starting point, for sure. But what this whole experience shows us is that managing a global crisis isn't about finding one perfect number. It's about understanding this entire, interlocking system of science, human behavior, and culture. Which, of course, leaves us with one final, very important question. Knowing all this now, what's the one thing we absolutely cannot afford to get wrong next time?